Thank you all for coming. Yep, today I'm going to be talking about OQGraph, which is a plugin that lets you use a SQL database to do graph operations. Just quickly look at some introduction to a bit of graph theory very briefly, and MariaDB storage engines, and a couple of examples on how to use OQGraph. And then I'm going to share some of the things we had to do to get OQGraph to a point where it could get merged into MariaDB, which is the community fork of MySQL. And we're not talking about this type of graph, we're talking about this type of graph. So basically, if you don't know a lot about graphs, it's effectively just a collection of nodes which might have information on them and the relationships between the nodes, which is an edge or a link, various terminology from different parts of the graph. Graphs have their own field of mathematics called graph theory. There's some famous problems in graph theory. You may have heard of travelling salesman, which is one that supercomputers still can't solve in a very short period of time, where you want to try and get to every city on the map, only going to them once. Basically, there's the knight tour problem, where you're trying to see how you can get a knight on the chessboard to go to every cell as well. So there's various academic reasons for using graph theory. And there's various algorithms you can use with a computer to try and visit all the nodes in a graph. So you've got breadth first, where you go and try and you find your nearest neighbours, and then you branch out to the neighbours beyond that. Or depth first, where you want to try and get as far away as possible in one go, and then come back and trial the next one. And the shortest path algorithm, where you want to try and find the shortest path through a graph from one node to another particular node. And shortest is not necessarily in distance, because you might imagine you've got a map and you want to get there shortest. So the graph on a map has a bunch of nodes for places, and then the edges give you the distance in between. But you might also want to find the shortest path in terms of dollars, because you want to catch 3 buses or 5 buses, but they've got different prices depending on the time of the day. So we can talk about graph theory all day, but I'm not going to do that. But other than to know, it's useful in the real world for various real world problems. I've mentioned maps and graphs. Underlying LinkedIn, Facebook and all this other social media stuff is a lot of graph manipulation that's necessary to do that. And even in the Linux kernel, trees are used everywhere in the Linux kernel for all sorts of things, and the tree is a graph, so you can use these algorithms to deal with that. So we have graphs, we want to use them for mapping or other applications. However, in the real world, if you've got a massive volume of data, you probably want to use a SQL database. It's store data in rows, a table of rows of information. I know there are NoSQL alternatives as well, but if you want to do large amounts of data, you want to do queries with complication, SQL is probably the best way to go with that. And today I'll be talking about our OQGraph tool, which is a plugin for MariaDB. And I mentioned before, MariaDB was a fork of MySQL, because MySQL got taken over by Oracle, and a lot of people were a bit worried about that, so they forked it and made a community one, and now that's appearing in a distribution near you soon, or if it's not already. There you go, yeah. It's almost there in Debian, I believe. So if you have a graph, it's a collection of nodes. So for example, we've got A, B, C and X as our nodes, and there's links between them. How can you store that in a SQL database? Well, pretty simple. You just have one row in the database that describes the connection between the graphs. So here we've got a link between A and X, so that's one row in the database from A to X. It's got a weight. The direction is implicit. It's kind of context situational for the direction, depends on what you're doing. Like some graph applications, the direction doesn't matter. On Facebook, for example, 2 people are friends. Well, you can't not befriend someone in Facebook and not be their friend as well, so there's no direction. On Twitter, however, if you had a graph of Twitter followers, people follow people, so you would have one arrow going one way and one back the other instead. So you could query this information in the graph. So just going back again, do it. No, it's not. Yes, it is. We have a pretty simple looking table, However, when you want to manipulate a graph, it's actually really difficult to do that in SQL. I mean, here all I want to do is get a list of distinct vertexes. And as you can see, there's 5 rows, but depending on directions, B could be a source or a destination. I've got to write a union query just to get that. And, you know, unions are not always the best thing to have. If I want to do a breadth first search to traverse the nodes in a particular order, that's the pseudocode, and I'm not even going to try and do that in SQL. So that leads us to OQGraph. About 10 years ago, some people might know Ian Wentz. He invented this method for trying to access the data in a SQL database without having to write complicated SQL. So we have this concept of a virtual table where you have the underlying graph table like I showed you before, then you have this virtual table which has a way of accessing the graph that makes it look like a graph, and then you can go through and run the operation like a breadth first search, and you query the virtual table, and all the hard work of doing the breadth first search is done in the storage engine. The storage engine is a plugin for MySQL and MariaDB that is used to abstract the SQL query from the data and how it's stored. And basically talking about a storage engine. You may have probably heard of storage engines before and not realised that you've got DB, MySQL, if you use MySQL, and there's all sorts of very special purpose ones. In our case, the storage engine presents a virtual table so you can do your graph queries, but then actually hides all the computation from you. So I mentioned before, you have a normal table. This is where we stored the graph we showed you before, but in your application you want to do a query. The OQGraph plugin table actually does the work, and under the hood that reads the underlying table. Now how does this actually work? OQGraph features special columns. One of them is called a latch, which is like a command column. When you do a select query on the virtual table, you actually have a where clause, and in the where clause you describe the algorithm you want to run. So you go select from the table, when you set this latch column equals to breadth first search, for example. So the latch decides what actual computation is run on the data. There's a few different ones that are implemented at the moment. I'm just going to skim through some of this stuff because you can come back and read that after. But you can change the latch column and you get an open breadth first search, or you can do a shortest path search, or you can query the vertices without having to do a union query, and you can find all the neighbours of a node and all these other graph operations that are really easy to talk about but nearly impossible in SQL. So I've got a couple of real world examples. I'm just going to quickly skim through them. So we have an underlying table, and you populate that with nodes like we showed before. You notice the ones I've highlighted in red. This is how you create an actual OQGraph table. So MySQL and Maria tables have properties or metadata on the table itself, and we use them to link the IDs of the ends of the graph links back to the underlying data table. And then I can just go select the vertices without having to do a union query, or more importantly, I can find the neighbours of a node without having to try and do some super tangled SQL query. Or I can use a breadth first search and find all the nodes reachable using that algorithm in one simple line of SQL without having to even look at the algorithm in Wikipedia and try and work out how to do it. So there's a few, well, we've pretty much covered the advantages of using OQGraph. You have a normal table with all your normal data, you write the virtual table, and then you just do a simple query using the latch. And you can join the results and do whatever you need to do. And that brings me to the next point, which is there's a few constraints. We implemented the algorithms using Boost Graph library. It's implemented using a handler class, so it's a standard plugin for MariaDB, so you can turn it on and off. This is a similar diagram to what I had before. So you have a select Maria database, has a query optimizer, which does the hard work of working out, okay, I know I need to get to your virtual table to get the data. The plugin then gets called, it does the magic of the graph algorithm and returns you a table. So more importantly, we've just recently, after about a year of effort, had this merged into MariaDB. Before they let us do that, we had to have a fairly comprehensive test suite because MariaDB is used now by WordPress and Wikipedia, and pretty major companies. They don't want the database crashing out from underneath them, so every test has to pass. MariaDB features a thing called MySQL Test Run, which is a pretty awesome tool. It's written in Perl. It basically lets you have a whole suite of test cases or SQL scripts. It runs them and then it compares the output, and if anything varies, if there's a crash, the test fails, you have to go and fix it. One thing I noticed is the Debian people, when they're packaging this, they actually run all the tests when you build the package. So they won't even, you can't even produce a deb package for Debian without having passed all the tests. So all the different storage engines in MySQL have these suites. When you run an MTR test, one thing it does, it's like a typical unit test, say in C++ or another language. It'll run the script and then it'll create a fresh database for each suite of tests, so you don't have to worry about your data interfering. I've got a brief example here. It's pretty simple to run the tests. You just tell it which suite you want to run and it runs it. And then you record. So what you usually do is you develop a set of SQL scripts you want to test, and then you record the results when it's working correctly. Then you come back 3 weeks later, you've written some more code. Here I've deliberately introduced a typo, and it will pick up in the results. It gives you a diff where your test failed because the output has now changed. So that means you can go away and fix that and get it back. So, and there's a few other bits about that here. Now, of course, we've got a MySQL test suite now. What happens if your database crashes while you're trying to run your SQL test suite, or someone uses it, they've tried to do a query, they've had a crash or some other problem? Well, we can write some MTR code to try and exactly replicate their situation, but we still need to try and debug that. Now, the code in OQGraph, it uses Boost Graph library, which is heavy on templates, which makes for some interesting debugging. It's also directly interfaced into the MySQL core for accessing underlying tables, so there's a lot of legacy C code in there as well. So it's a bit harder to debug than normal, but the MySQL Test Run suite will actually let you spawn the database itself in a debugger, because normally you're running code, you've got the debugger is normally a separate process. The database is usually a separate process, like MySQL D is running. And then you have your own program which actually executes the SQL to the database, and that doesn't crash, the server crashes. So MTR lets you fire up the server itself in the debugger. So that's all well and good, but usually you're running an SQL and you've got a test and it might do a whole bunch of SQL queries before it eventually crashes. So, and the other thing is when the database starts, it hasn't yet loaded the MariaDB plugin. Now, one thing with GDB by default is unless the dynamic link library or the plugin or the SO has been loaded, you can't attach to an arbitrary line of code with a debug breakpoint. And so one thing I learned when I was doing this is you can go into GDB and go set BRE pending on, and now you can set a breakpoint of code that is not in memory, it doesn't exist yet, which is really quite handy. And the other thing is when you're trying to debug a SQL statement and you want to have a breakpoint, but it outputs 60 lines of good SQL results before the database crashes, that can get really tedious going, continue. So GDB will let you script some stuff. I can say in this example, I can set a breakpoint and then I can ignore the first 4 calls of it before I finally break. So that's really handy if you want to, if your SQL query crashed on the 4th result, I can set a line of code to a breakpoint and then not have the debugger keep asking me. Because generally, of course, I want to debug. I can see in my SQL output the query results crashed on the 5th one returned, so I want to break on the 4th so I can step through and try and work out why the 5th one crashed. More importantly with GDB, I can actually have it run an arbitrary set of GDB commands when the breakpoint is reached. So in this example, I've set breakpoint number 1, and then I'm saying for command, I'm going to run a command on breakpoint number 1 where I'm actually going to set a second breakpoint in a different spot. So I can, because I might have a piece of code that gets called 700 times, but I don't want to break in that until after some other piece of code is run 60, for example. And the other cool thing is you can make them as snippets in the .gdb init file if you feel like it. Going too fast. Yes. Anyway. So OQGraph is now merged into MariaDB, so if you wanted to, you could pull that off of Launchpad and have a play. One thing I found is Launchpad, for some reason, is really, really slow at downloading. So in the end, I worked out there's a thing called Git BZR in the newest Git, which actually lets you clone off of BZR into a local Git repository. So then once it's on your computer, you can do all your layout branching and everything else and clean it in revision history, and then later on push that back to BZR when you need to. So that's one of the most useful tools I discovered while doing this project. There are some unofficial mirrors on GitHub. It was interesting, the first talk this morning, I'll be having another look at that. See if I can do something similar with BZR. I've just talked about that. Looking forward, we want to try and implement a few more graph algorithms. We also need to tidy up the code a bit, but it's still fairly prototype. It'd be handy to be able to have a plugin for our plugin, so anyone can come along and write a new graph algorithm without having to know about how to do a plugin. But how to do a MariaDB plugin. And the Windows build is broken, but I'm guessing most people don't care too much about that yet. And that's just the difference between MySQL and MariaDB. And I'm pretty much done.
So does anyone here have a question or two for Andrew?
The slides are going to be provided.
Yeah, I'm going to post them up off my website. So,
Okay, so Jeremy?
Feel free to say this is just a non-issue, but is it a problem that it only supports MyISAM pages?
I don't know.
What's the question, sorry?
Oh, sorry.
Why does it only support MyISAM?
Yeah, oh, sorry. He wants to know why it only supports MyISAM. This is the inventor, Ian. So.
There's a microphone just said if you talk.
Okay. It doesn't. Version 2, which was the previous edition, which you may have played. If any of you have played with it up to now, it was probably version 2 that you played with. I did. Yeah, nah. It didn't. I did read the slide. It didn't actually say that. Anyway, V2 kind of behaved like a memory engine, so it had its own storage, but it wasn't persistent. Version 3 works on top of an existing storage engine. That could be MyISAM, can be InnoDB, can be anything else you like. It doesn't matter. It could actually be memory engine. It could be through the MariaDB connect engine, connect to a different database that is not actually SQL at all, somewhere else on the other side of the planet. It won't work very fast, but it will work. So it essentially doesn't care what's the underlying engine. It has no knowledge of the underlying engine. It uses the normal interface to get to it, and it doesn't care what's underneath. Okay?
I guess to correct my slide, it's only being tested on MyISAM. So I've never tested it on anything else. So I guess if you want it to work, use MyISAM. If you want to volunteer to test it on one of the other storage engines and then submit patches, that would be awesome too.
Anyone up there? Yes.
How scalable is it? I mean, if you have set up a graph, sort of few million nodes and all that sort of thing, what sort of, have you tested it for sort of performance of those sorts of numbers?
The most I've tested it with is about 10,000, so I haven't really got that far into it yet. There's a thing called the Tree of Life, which is a well-known graph. We're going to load that in and see how that goes. So it's a work in progress, I suppose.
We've played with the 6 degrees of Kevin Bacon using IMDb.
Say that again, please.
The 6 degrees of Kevin Bacon using using IMDb. So that is which actor connects to which actor through Kevin Bacon. Yeah, okay. Well, because you can, you know. Which works out to be, I think, about 45 million vertices. Now, that didn't work at all nicely in version 2 because it behaved like a memory engine. So the key problem was not speed, but running out of memory. If you had enough memory in your system, it could run, and my friend Anthony Curtis has actually done that. In V3, I don't know if he's he has actually tried that. It is not super fast. That said, the code is not optimized in that direction yet. The purpose of V3 was to actually get rid of version 2, make sure it actually works on other engines, and you know, get that new process going. And the key issue was there, getting it merged back into MariaDB, which of course is a long process, because it's replacing an entire code base with an entirely different code base and making everybody in the environment happy with that. So that's now happened, so we can work on optimizing it. It may actually, making it fast may actually involve getting rid of the boost graph library. It is a monster. It is absolutely daft. Apart from it being C++ with templates, it is, you know, and we will have opinions on it, but it's not fantastically documented. I mean, it has documentation, but when you actually try to use a particular function, you find out that it doesn't quite work that way.
Do you have any idea of what sort of numbers it will, you know,
we know it will work with up to a couple of million vertices, semi-decently, depending on what you're trying to do with it. Obviously, we'd like to improve that. And because it is a clean plugin, actually fixing things up now that it is in the MariaDB 10 tree is relatively simple. Whatever we change in the code base doesn't change the core MariaDB server. So the level of apprehension with other developers should be relatively low. It's absolutely clean as a plugin. Does that make sense? So if you were to unload OQGraph, there's absolutely no OQGraph code in the MariaDB code base. It is purely in the loadable library.
Might take one more question. Yeah, up the back.
I noticed the next talk is also about graph databases, and I was just wondering what sort of use case you would have for this product, which is, you know, built off a traditional engine versus a native graph database.
Well, I guess a lot of people have a lot of data already in a SQL database. And a lot of people have MariaDB or MySQL, and they might want to get access to that quickly. So there'd be first use case. Ian probably amplify that too.
I think that pretty much summarizes it. I mean, there are awesome dedicated graph databases, but that's what they do. Most of your data will not be in there. So I guess what OQGraph adds or provides you with is an option for convenience. It should be approximately the same speed as a dedicated graph engine, because it uses the same algorithms. In some cases, it might actually use the same code. Yeah. So the slow bits would be the interfacing with the underlying storage engine. That is where we need to work on the optimization. You know, fetching individual vertices from an underlying engine in individual calls, that at the moment is the slow part in the whole process. So depending on which engine you use, and maybe a little bit of extra caching and so on, we can vastly improve on that. There are ways to make that faster. So yeah, I would say generally it's convenience. You can grab a set of data out of a regular engine, put it in a dedicated graph engine and do queries there, and then join it back onto other data that you have. That may be a really good way of doing what you need to do if you have specific needs. There are things that the graph engine currently can't do, the dedicated graph engines can.